So the first thing we had to do was find what's called critical values. The first critical value, I just denote it CV. The first critical value is what makes each fraction undefined. Pick a number I can plug in that makes each fraction undefined. So take a look at each of the fractions up here. There's nothing to plug in there. There's no variable. And again, I'm only looking denominators with undefined. There's nothing to plug in there. The only thing I could plug in for in a denominator-wise is this fraction right here. What number could I plug in for x that makes this equal to 0? 2. So that tells me one critical value is 2. I will do something with these critical values in a minute. Please keep in the back of your mind, everybody, when you write your answer, whether it be with parentheses, brackets, or inequalities, the undefined critical value will always get a parenthesis and will never get an or equal to. Let me say that one more time because that's key. When we go to write our solution, if we write it with brackets, parentheses, whatever the case is, 2 will always get a parenthesis. The undefined value will always get a parenthesis. If I write it in inequality notation, all right, with the less than or equal to or the less than sign, the 2 will never have the or equal to. The undefined value never has the or equal to. Okay, so please keep that in the back of your mind. All right, there's one critical value. How do I find others? We solve this for x. I take that less than or equal to, and I make it into an equal sign. And I solve for all possible values of x. This is what we have a lot of practice with last week. I need to find, remember our goal, get rid of these so I can solve something on top. Get rid of all three denominators, so I need a common denominator here. Common denominator, is anything repeating in those three? Did anything repeat? No. So I need to take all three denominators. I need to take the 4, the 3, and the x minus 2. Can I just simplify that a little bit to what? 12 times x minus 2. So there's my common denominator. Questions? Then I take it, and again, I'm going pretty quick here because we reviewed this. We did this last week for 2 days. Now I multiply each of these by 12 times x minus 3. 12 times x minus 3. 12 times x minus 3. Your denominator should go now. If they don't, you pick something wrong to begin with for the common denominator. X minus 2, thanks. There's always one. One contribution to the class. Way to go. Okay, let's try that again. X minus 2. All right, here we go. Let's go quickly here. Again, this is all from last week. So ready? The 3 and the 12 go. I'm left with 4. The x minus 2's go. Left with nothing. The 4 and the 12 go, and I'm left with 3. Okay? Be careful when you start multiplying. Look at my first fraction. Does everyone see how I have 3 things I got to multiply? 3 of them. Be careful. You can multiply 2 of them right away. 4 and x and get 4x times that x minus 2. All good? All right. Be careful now. What do I have to distribute here? It's going to be minus 12. And then over here, whoa, we got a lot to worry about, don't we? I'm going to write it all out. 3, I got that x plus 1 in the numerator and that x minus 2 that was left. How you deal with that is on your own. Okay, let's keep trucking. 4x squared minus 8x minus 12 equals, again, oh, this does not go to both of them. It only goes to one when you distribute. Don't think it's like do-do, 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 do-do. No, stop being embarrassing, all right? It only goes to 1, all right? It's only going to go to 1. 3x plus 3 times x minus 2. Whew, we all right. Come on. I don't think I can combine. Oh, that's, nope, I'm good over here. Can't do anything, right? Okay, so let's keep going over here now. Double distribute. 3x squared plus minus 6x plus 3x minus 6. Everyone all right when I double distributed there? Keep trucking. Here we go. Yep, this was a long one. I knew it. 3x squared minus 3x minus 6. Guys, when you see an x squared, we've talked over and over, you're probably going to have to do what when you see an x squared? Factor, factor, factor. And you can only factor when one side is equal to 0. So let's move all of this to the left side so I have a positive x squared. So x squared, you tell me here, move the 3x over. What were we left with? 5x? Move the 6 over. What were we left with? Minus 6 equals 0. Factor it. Plus 6 minus 1. So we ended up with x equals negative 6 and x equals positive 1. There are other two critical values, negative 6 and 1. Yes? Oh, here we go. New girl starting already with me. It's got to add to a positive 5, right? Add to a positive 5. 6 minus 1. What did I? Oh, new girl. Okay, I get it, new girl. Calm down. No one else is going to challenge me there? Better? Okay. So let's go back up now. 6. And I did this one on Friday too, so I should be at this point and getting it right, but guess not. Everyone okay now with my 3 critical values? All right, now, what do I do with those 3 critical values? I put them on a number line. So I have negative 1, I have, 2 and 6. Now what we have to do is test values. How many values are we going to have to test here? 4 values to test. All right, it's up to you what you want to test. I'll show you how to test if you weren't here, but I don't have time to everyone test it. So we can say we can test negative 2. Let's test 0 there. Let's test 3 here and 7 here. Okay, somebody who was here on Friday, how do I test? I take each value, store it into my calculator for x. So take negative 2, store it in for x. Go up to the left-hand side, plug it in. See what number you get out. Do the same thing to the right side. Plug it in, see what number you get out. Compare the two. Is the left side less than the right side? If the answer is yes, it's an answer. If the answer is no, it's not an answer. So for these cases here, because I want to go quickly, this was good. This one was not good. This was good, and this one was false. Okay, so the numbers I plugged in did not work for 0 and 7. So how do I write this now as an answer? Ready? How do I write this as an answer? Well, what did we notice? Everything to the left of negative 1 worked, correct? So how can I write that? Got my braces. X such that x is, how do I write that? Okay, now let's talk here. Did this value make the fraction undefined for my critical value? Did this fraction make it undefined? No. And it's got an or equal to. So I am going to put x is less than or equal to negative 1. The original problem had negative 1, had the or equal to, so did my answer, unless it's a undefined critical value. Okay? If this made it the fraction undefined, I would not put the or equal to there. Okay? Did not work. What else worked? Anything between 2 and 6. Ooh, how do I write that? Anything between 2 and 6. So I have or anything between 2 and 6, what do you think these signs are going to look like? Well, they're all going the same direction. Should I be putting an or equal to on one of them? And the answer is yes. Which one? Which one was the undefined critical value, 2 or 6? 2, so that's not getting it, so 6 will. Interval notation, because I want you to make sure you can do both. Interval notation. How do I write that in interval notation? Everything less than -1 or equal to it. -1 all the way to what? Negative infinity, or positive infinity always gets parentheses, comma, -1. What should the 1, -1 get? Include, so it should get brackets, yep. And then how do I write 2 to 6? Not including 2, but including 6. Not including 2, so 2 should get a what? Parenthesis. 6 should get a, if it includes it, a bracket. And you guys remember what I had you put when you had 2 separate? The union, yep, U. Nice job. Good memory. So either one I would accept on Wednesday's test. I am not going to force you to do one way or the other. So you guys pick right now, 48 hours ahead of time, which one you prefer. All right, that's a lot. It's a lot right there. As tough as they come. Again, I highly recommend you try the assignment problems. There's only 4 of them. So, all right. I'm not going to ask for questions right now from the assignment. I'll wait to the end of class because I want to make sure I get through what we need to right now and it doesn't take too much time. Okay. Questions from you guys? Got your graphing calculators? Okay, fire them up here. Here's what I want to do today. I want to now graph all these we've been working with. We've added fractions, subtract them, multiplied, divide, solved for them, put an inequality with them. Now on this final day of the unit, I want to graph it, and I want you to tell me something about the graph. Okay? Tell me something about the graph. So what I'd like you to do first, using your graphing calculator, go to your y equals screen right now, 4 over 4 plus x. And let's see what it looks like. 4 over 4 plus x. Take a look at your graph. If anybody's graph looks a little strange, maybe you've been playing around with the settings, playing around with your calculator on your free time because you're that kid, let me know. Four over x plus 4. Anybody's not looking like this because I can get it back to the original settings here. Let me know now if your graph's not matching mine up here because you have a different looking graph going. We're good? Everyone else is good? Okay. Go to, on the top, hit zoom. And then it should say standard, maybe number 6. Just check. And then go ahead and hit number 6, enter. And then hopefully it'll go to regular settings there. Good? Okay. Anything else? Everyone else is good? Yes? So we can answer some questions now. All right, let's see if I can do this. Let's see, guys. Stay with me a second. See that? Guy's a magician. Unbelievable. Awesome. All right, here we go. Let's answer some questions based on the graph. Because here's what I want to get you today. Use the graph, and then we're going to put the calculators away and do it algebraically. All right, solving these questions here. All right, domain, x or y values for domain. X values. Okay, so let's look at the x-axis here. Do you see any x value? And the answer is yes, there is. So take a look. Do you see any x value that does not have a point on the y-axis here? Do you see? So here you go. Ready? This has a y value. That has a y value. Y value, y value, y value, y value. Do you see any x value up here that does not have a y value to it? It's blank. All right, it's blank. Do you see any? The answer is yes, it's up there. So don't tell me every x value has something. All right, it's up there. Look at your graph real quick. Nope, that's got something, 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 something. Anybody see an x value where it's basically a blank here? Jack? Everyone take a look at -4. If you take a look at -4, it doesn't have an x y value. Everyone see that? So our domain is everything but, Jack again, -4. So how do we write that? Here you go. D equals x such that x cannot equal, what's the value? -4. Hey, let's bring this together here. Look at that equation you just plugged in your y equals 3. And -4 is not in the domain. Does that make sense? Somebody tell me why here. Come on, kids. Bring it all together for me. Gianna. One more, a little louder so everyone can hear this. -4 makes the fraction undefined. Everyone see that? Perfect. Way to go. Yep, go ahead. Give your sis some knucks. Good job. Perfect. All right. Range. Range. Do you see any y value that's not represented? And here's a hint. This is not touching the x-axis at all. It's coming very, very close, but never touching. So ready? There's a y value here, here, here. There's a y value here. Definitely at 1. It crosses it. Here, here. What y value does it never, ever hit? Hello, Hannah. 0. Perfect. All right. So our range is going to be y such that y cannot equal, Hannah, 0. And you can't tell that from the equation, but I got a trick for you later, so settle down. All right. Y-intercept. What do you guys know as the y-intercept? Where it crosses the y-axis. Where's this cross the y-axis? At what? 1. All right, so we say the y-intercept is 0, 1. You can just say 1 if you want. That's fine. Either one's acceptable. Everyone good? Questions? Anything answering those? There's more, isn't there? Do I have that on the next? Nope, okay. I'll have to add it in. Oh. Okay, I don't know where that ended up being, but. Okay, next two are going to be pretty quick here. Vertical asymptote. Have you ever heard of that word asymptote before? It's where the graph never hit. So a vertical asymptote. Real quickly, go back to the x-axis. What value on the x-axis did not have a y value? -4, right? There's your asymptote. Here, watch, ready? I'll draw it in. There you go. X equals -4. There, that's the equation for your vertical asymptote. X equals -4. It matches your domain. It matches your domain. What about for the horizontal asymptote? Well, not make it any. Remember, it's an equation, so I just can't write down 0. Y equals 0. Yep. There it is right here. Put it in green. Okay. So the horizontal asymptote never the graph never touches, comes very close, but never touches. Same thing with the vertical asymptote at x equals -4. Questions from you guys? Okay, next one we got. Go ahead, clear it out of your y equals screen. And we have 2x plus 1 over x minus 3. Make sure we match before we can move on. Everyone good with their graphs? Matching mine here? All set? Do the magic again. Okay. What was the highest number we had in here? Why don't you calm down? I have the pen. Okay. 21, correct? Okay. So just so you know, instead of just calling on random people, because I feel like I have to call on everyone before I call on somebody a second time, I have everyone's assigned a number, and if your number comes up, you answer the question. So you're 22. Okay, good. Okay, what's the domain? You can cheat now if you want. You could take a look at the denominator, or you could take a look at the graph. Either way, which x value does not have any y values to it, or you can look at the fraction and cheat a little bit, because that's what I'm going to have you do at the next example, is just look at the equation. So what is my domain here? It looks like everything but what? Your quota of random bits? Wow. Denied. Are you this 4 years doing this? I've never seen that. My quota. And literally this is the first time I've used it today. I did not use it in my first period class. All right, forget you then. All right, what's my domain? 3. X cannot equal 3. So make sure we write this correctly. Denied. Wow. That's funny, Hoop, huh? Okay. Funnier that or your quiz grade? Oh, he came strong right there. He came strong. You're darn right. Okay, range. I haven't shown you the trick yet, how you can use the equation to find the range, so we're going to have to go back to the graph. All right, tell me what y value is not even represented on here. And remember, this just levels off here. What y value is not represented up here for a range? Go ahead, Carter. 2, yep. So there's my range. Y such that y cannot equal 2. Okay, take a look. Range is what values, Matt? Y values, right? Yeah. So ready? I'm going to go to each tick mark here. Ready? Here's the one y value. It's there. I got it. Got it. Got it. Got it. Crosses here at 0. Got a y value here. Got a y value at 1. Look at 2. I go in both directions. There's no graph there. All right. I go up to 3. Got a graph. Good so far? Okay. So that's why I'm saying it can't equal 2. You good with y can't equal 3? Same thing. Now I'm going to go here now. Everywhere I go on the x-axis has a point above or below it, except for 3. Good. All right, y-intercept. Not as easy as the last one, is it? Or you can just say, oh, it's 1. It crosses at 1. Who knows what that is? I'm going to go -1/2. Well, it might be -1/4. There's a lot of arguments there. All right, how exactly do I find out what it is? Well, remember what the y-intercept is. The y-intercept is, okay, let's go here. The y-intercept is when x equals 0. So what I can do is I can go back up here, plug in 0 for x. That will tell me the y-intercept, yes. Okay, why don't you settle down so I can teach? Thank you. Okay, so I want to know when x equals 0, so I'm going to go back up. 2 times 0 plus 1 divided by 0 minus 3. And yes, some of you are already seeing, you can go to your table on your calculator, look at 0 in the x column, and tell me the corresponding y value. So what are you finding right now? That comes out to be -1/3. You can write it like that. That's acceptable. Or you can put it as 0, -1/3 as a coordinate. All right, vertical asymptote. I look at my domain. My vertical asymptote is going to be the line x equals 3. And my horizontal asymptote is going to be y equals 2. Okay. Any questions about that? Because all I need to show you right now is, without graphing, how can I find the range, the horizontal asymptote? Olivia? Yes, for now, yes. Yep. Yep, good question. Other questions? Okay, here we go. Let's find out the little tricks here now. No graphing allowed. We're done with the calculators. No graphing allowed. You can put your cover on them, whatever you got to do. Okay? No domain or range here. All I want is horizontal, vertical, and the y-intercept. Okay? Let me start with the vertical asymptote. All right? Vertical asymptote. I'm just going to denote VA. Okay? The vertical asymptote. That will be where the fraction is what? Undefined. All right? The vertical asymptote is whenever the fraction is undefined. So you tell me, for what value is this fraction undefined? X equals 2. So that's where my vertical asymptote is, at x equals 2. That vertical line going through 2. All right, you ready for how to find the horizontal one now? Because we don't have a range to look at, so I just can't copy down what the range is looking at. How to find the horizontal asymptote? It depends. Take a look at number 2. First of all, let me talk about that concept right there. If the degree, what do I mean by degree? Hopefully you talked about it last year. Degree. Good talk. Anybody? No? Nobody wants to drop knowledge? Degree is the highest exponent. Okay. Oh, were you? Then say it. The degree is the highest exponent. Okay? And it all depends. If the numerator's degree is bigger than the denominator, we're going to say something. If denominator is bigger than numerator, we're going to say something. And if they're equal, we're going to say something. So let's just go, forget trying to remember them right now. Let's just go to our problem right now. Do you see any variable in the numerator? So we're going to say that degree is 0. Okay? What's the, everyone see the variable in the denominator? What's the exponent there? What's the exponent on this x? 1. Ready? So we're going to say the degree in the numerator is 0. Degree in the denominator is 1. We all see that. No variable. Degree equals 0. Down here in the denominator, degree equals 1. It's the highest exponent on any of the variables. Okay, so let's see which one this falls under. Ready? Numerator is greater than the denominator. True or false there? Is the numerator greater than the denominator? Nope. Okay, so it's not going to be that one. Numerator is less than the degree in the denominator. Is that what I have here? Yes, so the horizontal asymptote is the line y equals 0. Okay? If the numerator is less than the denominator, the horizontal asymptote will be at y equals 0. Which is another name for what? Anybody? Y equals 0? That's another name for the x-axis. Okay? And finally, my y-intercept. What did we say last problem? What can we plug in? Plug in 0 for what variable? X. So here we go. So -4 over 0 minus 2. My y-intercept will be 2. Or again, we can write it as 0, 2. All right? Questions? Okay, I'm going to go around to the groups now, and anybody in the group can answer. Let's take this first one. I always like to do vertical asymptote first because it's the easier of the two. What makes the fraction undefined? Fellas, here we go. What makes this fraction undefined? So it's going to be x equals 1. Hey, challenge question. Fellas here. Oh boy, I might regret this. If you already know the vertical asymptote is at x equals 1, what's my domain? All right, what do we got here?
We're going to go with x, 1, 0.
1, 0. When have we ever written the domain like that? Hey, quickly here, Goof Troop. Look at the domain and remember this from the beginning of class. The vertical asymptote was x equals -4. The domain was x cannot equal -4. So going back now, apply that knowledge right here. So if the asymptote's at x equals 1, my domain is x. Somebody please help. X cannot equal 1. So my domain would be x cannot equal 1. Good? Everyone see how they relate? Vertical asymptote and domain. All right, horizontal asymptote. Horizontal asymptote now. That was painful. Ready? Brendan, what's the degree in the numerator? 1. Degree in the denominator up here. 1. So what are you telling me? Degree in the numerator and denominator are the same. What do we got to do if they're the same to find the horizontal asymptote? If the degrees are equal, the horizontal asymptote is the line, ready? Leading coefficient divided by leading coefficient. Ready? Go back down. What number is out in front here? 4. So it's going to be y equals 4 divided by, ladies in the back, leading coefficient in the denominator, 1. So my horizontal asymptote is y equals 4. Should I go back and try this now? Gentlemen, if my horizontal asymptote is y equals 4, what would my range be? If my horizontal asymptote is 4, what would my range be? What is it? Y cannot equal 4. There we go. Everyone's seeing the relationships now. Thank you, fellas. All right. And then finally, my y-intercept. We'll go with these ladies over here. How do I find y-intercept? What's the easiest way? So 4 times 0 plus 2. 0 minus 1. What do you got for me there, ladies? -2. Yep. Again, or I could write it 0, -2. Wow. Unbelievable, everybody. Questions? Do you think you could try the next one in about 2 minutes, maybe less, within your group or people around you right now? Okay, again, horizontal, vertical, intercept. Get after it. And a little hint, what can you do to the denominator to find the vertical asymptote? Factor it, yep. I'm just going to give you a little tip here. You might have 2 vertical asymptotes here. What makes this equal to 0? There's actually 2 numbers that make it equal to 0. Go, go, go. Nobody cares about the numerator, just the denominator for undefined. Back to business. Vertical asymptote. Hopefully you tried to factor x squared minus 1. Found out when it was equal to 0. Because there's actually 2 vertical asymptotes here. 2 vertical asymptotes. Who's got it? Carter, go ahead. So x equals 1 and x equals -1. Two vertical asymptotes. Are we okay there, solving that? Okay, what about the horizontal asymptote? What did you notice about the degree in the numerator versus the denominator? Which one's bigger, numerator or denominator? Numerator, so you looked at top. This is the first time we've encountered this. If the numerator is bigger than the denominator, degree-wise, what do you know? There is no, not 0. It's not y equals 0. There is no horizontal asymptote. There's not one that exists. Okay, y equals 0 is different than none. And then your y-intercept. Hopefully you plugged in 0. 0 to the 4th minus 2 over 0 squared minus 1. You ended up with, what'd you end up with here? 3. I got a 2. -2 over -1 gives you 2, yes, or 0, 2. How comfortable do we feel here before I throw you one change up, one curveball here at the end? We okay finding everything on your own? And again, am I going to blame you if you use your calculator? Nope, you have it available to you, so why not if you use it? Okay, what is so different about the equation in number 6 versus the other 3, 4, 5 we've already done today? Anybody see a bit? And it's very, very simple difference. It's more than just a fraction, right? It's -8. Do you remember from algebra last year or from 9th grade algebra what that -8 does? What it actually does, like here's 3 over x minus 7. That's a graph. But now that I subtract 8, anybody know what's happened to that graph? Okay, it moves where? Down 8. Okay, so this graph is going to go move down 8. Keep that in the back of your mind. So domain range, here we go. Domain. When's the fraction going to be undefined? That's not going to change. X, so the domain's going to be x such that x cannot equal 7. Perfect. So while we're here, can we go vertical asymptote? What's your vertical asymptote going to be? Oh, make it into an equation. X equals 7. Okay, I'll do range at the end because I'd like to know what the horizontal asymptote is before I tell you what the range is. Okay, numerator. What's the degree in the numerator? 0. What's the degree in the denominator? 1. So if the denominator's degree is bigger, go back and look if you need to. Look up top. What's my horizontal asymptote? Okay, hey, whoa! Y equals 0, right? But, you're going to say something, Hannah? You sure? It might have been right. Okay, yes. Hey, look, everyone focus in. Yes, for that, it's y equals 0. But what am I doing to the graph? Going down 8. So it's not at y equals 0 because I shifted everything down 8. It's actually at y equals -8. Okay, and you can see that by graphing it, which means my range is going to be what? Y such that y cannot equal -8, the horizontal asymptote. Okay, so just watch out for that. Instead of y equals 0, we're shifting everything down. And then I think you guys can handle the y-intercept. It's going to be a decimal, but leave it as a fraction for me. So 3 over 0 minus 7 minus 8. Bless you. Good thing we have fraction templates, right? Anybody have that fraction negative? It's okay to open them up and use them. -59 over 7, yep. There you go. Guys, I'm asking 4 problems to try out tonight. 4. Big day tomorrow, quiz test review. Stop by if you need anything from me before Wednesday.